A couple of lessons ago, we did, I don't remember what lesson it was, but we did integration of odd powers of sine x and cosine x, right? And at the time, with odd powers, we could take something like sine cubed and break it up into sine squared and sine x, and that sine squared then could turn into, we could use Pythagorean identity, and it became 1 minus cosine squared, right? We did that type of thing. Even powers work a little differently, okay? So even powers, we are going to use, these are a variation of the double angle identities. So I know you guys, I already heard the, what, there's fractions? If we think back to, where is that page? The beginning of the year, that had all of our pre-cal identities on it. Right after lesson 4, we had a page with pre-cal identities. And at the time, your double angle formulas look totally different, okay? Because our double angle formulas back then are solved for sine x or sine 2x and cosine 2x. Well, what we're doing here is we're using the cosine 2x ones, the 1 minus 2 sine squared x, and the 2 cosine squared x minus 1. We're using those. But what you'll notice here is that instead of them being solved for cosine 2x, they are solved for sine squared and cosine squared x, because that's the form we're going to need them in. So, as I said, if you go back to, it's the pre-calc formula page back after chapter or lesson 4. These are coming from the idea that cosine 2x is equal to, I never remember which one, how each one goes, but the 1 minus 2 sine squared x, and then also the 2 cosine squared x minus 1. That's what we're using today, except they're solved in a slightly different form because we want them to be solved for sine squared and cosine squared. Okay? Now, do notice, did you guys catch the correction I was doing before I started the recording? I'm going to point it out, but right here. Your notes have that as a sine, don't they? It's supposed to be a cosine. So right there, notice I changed that. So note right there, that's a change from, it's just a typo. Okay, so as we look at example 1, integrate cosine squared x dx. Well, the problem is the power, right? Because, yeah, we can integrate. We know something to the second should be something to the third and all of that, right? However, the problem is when you do the chain rule and you take the derivative of the inside, there's no sine x in this problem. So in order to integrate cosine squared x, we have to change it to another form. And that's where we're going to use our double angle identities right here. So first thing I'm going to do is rewrite this. The integral of cosine squared x dx is going to be the integral of 1/2 plus 1/2 cosine of 2x in my parentheses times dx. So you're always going to be looking for an even power to sub in here. Now, of course, since this is two pieces added, you may not feel the need to write this out, but technically this can be broken into two integrals, right? So this officially could be rewritten as the integral of 1/2 dx plus the integral of 1/2 cosine 2x dx. Whether you write it out as two separate ones or not is up to you. What's the integral of 1/2? One half x, right? Because you just add a constant on. So the integral of 1/2 is just 1/2 x. Okay, got the easy part out of the way, right? Plus, on the integral of 1/2 cosine 2x, well, first of all, that 1/2, I could have brought that out front. I'm not really sure why I didn't, but So we know there's going to be a 1/2 here, correct? And we're trying to integrate cosine 2x. Are you guys okay with integrating cosine 2x? I think
It would have to be like 1/2 negative, like negative 1/2 sine 2x, right? Or no?
except positive.
Okay.
Yeah. Okay, so if you, I mean, basically what's going to come down to is we're integrating cosine, right? The integral of cosine is going to be sine. Because this is a 2x here, we're going to have to compensate for the chain rule because the derivative of 2x is 2. So what you're compensating with is going to be a 1/2. Now, if it helps, you could also think of like a u substitution here. And maybe you don't need this, that's fine. But if we say, okay, u is 2x. And I think I'll only do this on this one. I won't necessarily do it on all of them. What is du? Derivative of u is du. The derivative of 2x is 2 dx. And as we try and look at this, notice we just have a dx. So if I divide by 2, du over 2 is dx. And so I can use that idea that I'm not going to integrate quite yet. It's 1/2 times the integral. Cosine 2x, I can make cosine of u times dx, which dx is going to be a du and a 1/2, right? And so if that, I mean, that's the longer way to work it out. I think we're, you know, in case you're kind of like, okay, what about this 1/2? It does legitimately need to be there. So if I rewrite this out, 1/2 x we already had. The 1/2 times the 1/2 out front is going to be a 1/4. What's the integral of cosine? We already said that was sine. Now, sine of u, but if we want to go back to the original, it's going to be sine of 2x. And then, of course, because we are integrating, we need to say plus c. If you didn't like my u substitution, sorry, I won't necessarily use it next time. If you liked it, hopefully it helped you see it a little bit better. Okay, that was a basic one. Are we okay with that? Okay, shall we try the next one? Next one, we are integrating sine squared x times cosine squared x dx. Thoughts?
Well, we can split that into like the integral of sine squared x, the integral of cosine squared x, right?
Not with multiplying, you can't. We just have to leave it all within one integral.
So do we want to change them both? Or?
We're going to need to change them both. Yeah, I didn't say it was going to be pretty. Remember when we did odd powers, I said, you know, this one's coming first, which means we're going to like this one a little bit better. I'm not crazy about the even one either. So, okay, so our first step is, yes, we are going to change both of them. So sine squared x, I'm going to change into the equivalent double angle identity. And that one is the 1/2 minus 1/2 cosine 2x. Then I'm going to change the cosine squared x, which basically the cosine squared x, the only difference is it is a plus sign. So that's going to be 1/2 plus 1/2 cosine 2x in my parentheses, and there's still a times dx. Okay. What do we have to do with these two? Foil?
We're doing some. Yeah.
We are foiling, yes. Again, I didn't say it was pretty, did I? Okay, we are foiling. Nice thing is they're conjugates, though. 1/2 times 1/2 is 1/4. 1/2 times 1/2 cosine 2x is going to be what? 1/4 cosine 2x. But you have a 1/2 times a negative 1/2 cosine 2x. So realize these are conjugates, yes? So because they're conjugates, my inner and outers are canceling. And so the last, negative 1/2 times positive 1/2 is going to be negative 1/4. Cosine 2x times cosine 2x. What's cosine times cosine? Cosine squared. And we can do that because the insides are the same. So cosine squared 2x. So I have 1/4 minus 1/4 cosine squared 2x. What do you notice?
Something tells me we can do that a little easier than the other one.
What do you mean?
So, is it in a form that we can integrate it now, or do we have to do something with the cosine square?
Well, the whole point of today's lesson is being able to integrate even powers. In order to integrate an even power, you have to change it. So the good news is we did have 2 even powers. Now we're down to 1, but we have to substitute again. Okay? So we need to take this cosine squared 2x, and we need to replace the cosine squared 2x. So let's see what we have here. I'm still going to have a 1/4 out front minus 1/4 times, what are we replacing cosine squared 2x with? Look up at the top of your page, and it is 1/2 plus 1/2 cosine, what's that supposed to say right there?
Just cosine of 2x.
Okay, it says cosine of 2x. Now, if you go back here, I'm going to go back to my other screen for a moment. When it says that, this cosine 2x is based on what's the original piece? Cosine squared x. So this is saying when you do cosine 2x, it's 2 times whatever the value is in the squared piece. So when you look right here, what was the value in the squared piece? 2x. And so basically then at that point you're doing 2 times 2x, which is 4x. So you have to double whatever is there. Okay. Good news, we've got rid of the squareds. What can we do next? It's 1/4 minus 1/4 times this quantity in parentheses.
Now we can split it in 2, right?
In a moment, maybe. I wouldn't split it yet because this 1/4 here needs to distribute. Okay, it's distributing to the 1/2, and it's distributing to the 1/2 cosine 4x. Now the 1/4 out front is still staying 1/4 minus, what's 1/4 times 1/2? 1/8. And then we have minus 1/4 times 1/2 cosine 4x. Well, 1/4 times 1/2 again is minus 1/8, except you've got the cosine 4x times dx. If you want a step, you could collect your like terms right here. What is 1/4 minus 1/8? Which would reduce to 1/8. So 1/4 minus 1/8. I was going to go with 2/8 minus 1/8, which is 1/8. 2/16 is equivalent. So now I'm going to say the integral, putting that 1/4 and that 1/8 together, is 1/4 minus 1/8 is 1/8 minus 1/8 of cosine 4x dx. I promise we're almost there. Almost there. If you haven't already, Ross has been wanting me to do this for a couple of steps. We do have two pieces being subtracted now, right? I didn't want to do it quite yet earlier because I need to distribute and collect like terms. But if you want to, you can go ahead and break it up. It's going to be the integral of 1/8 dx minus the integral of 1/8 cosine of 4x dx. It must not want me to write on the recording portion. Okay. The integral of 1/8 1/8x, just tag on that variable. The integral of 1/8 cosine 4x. Well, I'm going to go ahead and write down my 1/8. What's the integral of cosine 4x?
Would be 1/4 sine of 4x, right?
Okay, yep. The integral of cosine is sine. Because it's of 4x, we're going to have to say 1/4 sine 4x. And then you can wait a step if you want until we clean it up, but I don't want to forget it, so I'm going to say plus c. So my cleanup step here, 1/8x minus 1/32 sine 4x plus c. I don't know about you guys, but I still like the odds better.
Yeah, that was pretty rough. I don't know the next one. You know, the last one is always the boss. So.
That it is. I won't deny it. Okay. I have the next screen ready for the next example because I didn't want to try and have to be writing down at the bottom. So I went and got the next screen ready. Ready for the next one? And before I, well.
This one is going to be that the conjugates won't cancel, right? So there's a bunch more terms.
Pretty much. Okay, so sine to the 4th x. We don't really have anything to replace sine to the 4th x with. What do you know about sine to the 4th?
It's 2 sine squared.
It's 2 sine squareds, isn't it? So you can think of this as the fact that it is sine squared x squared, if you will. So we're going to replace sine squared with 1 minus 1/2 cosine 2x. We're going to have to square that, which for visual purposes, I'm going to write it out as opposed to having it squared. So I'm going to have 1/2 minus 1/2 cosine 2x. And again, this is where you could write squared if you want. Or I'm just going to say times 1/2 minus 1/2 cosine 2x dx. So yes, like the previous problem, we're going to FOIL again. Unlike the previous problem, my middle terms won't cancel out. So it will be a little less pretty. Okay, first, 1/2 times 1/2. 1/4. Now, as you multiply outsides, 1/2 times negative 1/2 cosine 2x. So that's going to be negative 1/4 cosine 2x. Then when you do the insides, it's 1/2 times negative 1/2 cosine 2x. So, excuse me. So we're going to end up doing negative 1/4 plus negative 1/4, which is negative 2/4, or can I just go negative 1/2? I assume that's what I did here. So minus 1/2 cosine 2x. And then lastly, negative 1/2 times negative 1/2 is 1/4. Cosine 2x times cosine 2x is cosine squared 2x dx. We do have to do it again. Yeah, we got rid of one of our squareds, but we still have a squared. So, you know, it's a domino effect. You get rid of one, you'll eventually be able to get rid of both. Okay, so still 1/4, still minus 1/2 cosine 2x, plus, it's a 1/4, but what am I replacing the 1/4 with? Cosine squared 2x is equivalent to 1/2, it's plus, isn't it? 1/2 plus cosine of 2x, 2 times the previous amount. What's my previous amount? 2x. So that means I'm doing 2 times 2x, which is 4x. And in the parentheses, times dx. What do I need to do now? Okay, distribute that 1/4, keep everybody else the same. So the integral, it's still 1/4 minus 1/2 cosine 2x. And then we're distributing that 1/4. You have two terms you're distributing it to. 1/4 times 1/2 is 1/8. Plus 1/4 times 1/2 cosine 4x is going to be 1/8 cosine 4x. And hallelujah, I think we're there. If you want, there's a set of small like terms there, right? Add them together later, add them together now. What is 1/4 plus 1/8? So 2/8 plus 1/8 is going to be 3/8. So the integral of 3/8 minus 1/2 cosine 2x plus 1/8 cosine 4x. If you want to separate integrals, this is the place, right? I don't necessarily feel like you have to, but if you want to separate integrals, this is the place. Otherwise, let's go ahead and integrate. What's the integral of 3/8? x minus, I'm going to do this in pieces, I'm going to go ahead and write the 1/2 down. What's the integral of cosine 2x? Integral of cosine of something is sine of something. Compensate for the derivative of 2x, so we need a 1/2 out front. So that 1/2 times 1/2 I'll clean up to be a 1/4 here in a moment. Plus, I'm going to write my 1/8 out front. Integral of cosine of 4x. Well, integral of cosine of something is sine of something. Compensate for the derivative of 4x with a 1/4. And I'm going to go ahead and tag on my plus c. So if you haven't already cleaned it up, that's my job now. 3/8 x minus 1/4 sine 2x plus 1/32 sine of 4x plus c. Okay. Officially, your 2x's and 4x's, they should be in parentheses, just to kind of indicate that they both go with that. They are the inside of the sign. I have one alteration on the homework. Number 1 becomes 16 from 77. Okay.